Multi-layer neural network. We already studied perceptron and how perceptron is used to separate the classes of AND gate and OR gate. Now let us understand this multi-layer neural network. Now what is use of multi-layer neural network? We have seen using perceptron we can separate the classes for OR network or logic. So here with one line linearly we can separate this logic 1 and logic 0 class. Similarly for AND gate using this linear line we can separate the classes having output 0 and class having output 1. But if you consider XOR problem, we cannot separate this output with logic 1 and logic 0. Here we have to draw these two lines, or we can use this type of elliptical curve to separate out this classes. So it is not a linear separation of these classes. So in this type of example where we cannot separate classes linearly, we have to use a multi-layer neural network. Now this is simple feed-forward neural network. In multi-layer neural network, the first layer is input layer, same as a perceptron. Here number of inputs can be applied from x1 to xn. So these are the input nodes, and then these nodes can be multiplied, or these inputs can be multiplied by weight, and they are connected to next layer. So here two layers are shown and dot lines indicate that you can increase number of layers. These middle layers are called hidden layers. So these are hidden layers, and number of hidden levels or layers depends upon the application. If you add more number of hidden layers, then it is called a deep neural network. So it will have an input, then it will have a number of hidden layers, and then the final output layer will have. So here only one node is shown in the output layer. Again it depends upon application. The output nodes can be more than one also. Now here we are saying this is the node at the hidden layer 1, generally indicated or written as H1. So these layers will also have an activation function. So activation function you have already studied. So it will have an activation function. So this output of at each layer should pass through this activation function. So here activation function will be there. Depends upon application, we can select activation function. For this layer also the output should pass through activation function, and if it satisfies the condition of activation function, then only this node will be fired and output 1, logic 1 will be given to output node. Otherwise logic 0 will be passed to this output node. Now these are the weights. Weights should be assigned to this each branch. Bias is again used for each of these nodes. So here also bias is used, and the bias is again used for this output node. This output node again will have an activation function. So output should pass through activation function and then we'll get a output. So this is the simple example of multi-layer neural network. This is also called as a feed-forward neural network. We are applying input and we are proceeding this input in forward direction, and then we get a output. Now we'll see how to use this multi-layer neural network to solve the XOR gate problem. Now consider this multi-layer feed-forward neural network. It is having two input, x1 and x2. These are the branches connecting this x1 and x2 to the hidden layer. So here we are using only one hidden layer. So this H1 and H2 are the functions of hidden layer, and each hidden layer is having activation function. Again the weights are applied to this branches, and bias is also here used. Here bias is -30. At this node bias is 30. At this node bias is again -10. This output is again having a activation function, and after this we'll get a final output at this point. So how to solve this feed forward network, that we'll see. So here we'll check first condition, the condition 1, that truth table of XOR gate will check. First, when x1 input is 0 and x2 input is also 0. So we'll calculate the output which we'll get at node h1. So for example, suppose here output is y1 and here output is y2. So this is y2. So first we'll find y1 and y2. Here activation function is also used. So output at this node should pass through activation function. We'll assume simple activation function as a step function. So as you know that if output is equal to or greater than 0, then output of this activation function will be logic 1. If output at this node is less than 0, then output of this activation function will be 0. So we'll write the equation for output at y1. So that is x1, input x1 into 20. So we'll multiply x1 by 20 plus this x2 is also applied at this node. So x2 multiplied by its weight 20 plus there is a bias minus 10. So we'll add this bias minus 10. So actual you will get this type of equation if we add bias as minus 10. So y1, if you substitute x1 and x2, you will get x1 is 0, x2 is 0 and minus 10 is bias. So this minus 10. So since output is minus 10, which is less than 0, output is less than 0, so step activation function will give output as 0. So try to understand this. Here activation function is step function. So if output is less than 0, the output of this node will be 0. This is for y1. At y1 the output is 0. In the same way we'll find the output y2. So y2 equation directly I am writing here x1, that is 0 into minus 20, x2 into minus 20, x2 is again 0 plus bias is 30. So we'll get the output 30, and since this output is greater than 0, that is 30, the output of this node is 1. So y1 output is 0 and y2 output is 1. Now we have to find the final output. Remember that at final node there is again activation function, and for simplicity we are assuming step function only. So we'll find this y. So we can write equation at this node y1 into its weight, that is 20, y2 into its weights, that is 20, and bias is minus 30. So we'll write this equation for y. After finding this, it has to go through activation function. So here y1 is 0, we have calculated it as 0, y2 is 1, so this is 1, and bias is minus 30. So if you solve this, you will get here minus 10, and since activation function is simple step function, if output is less than 0, then output of this node will be 0. So y is 0 when x1 is 0 and x2 is 0. So first condition of XOR gate is satisfied. Now using this logic, you try to find the output for this inputs. All this truth table will check, rows of truth table you have to check using this network. So when x1 is 0, x2 is 1, try to find y. Remember that the input or output should go through activation function at each stage. And when x1 is 1, x2 is 0, and fourth is x1 is 1 and x2 is 1. Solve this and try to find whether this feed forward neural network can be used to implement a XOR gate or not. And